take this one step further. There now is no longer any controversy as to whether or not the field exists and whether or not we're connected. The question is, how deeply are we connected? In an experiment that was performed by the University of Geneva in Switzerland, a scientist named Nicholas Gizon did this experiment. He reported it to over 3,400 journalists, educators, scientists, and engineers in more than 40 countries on a Friday afternoon, July 25th, 1997. The experiment is called the twin photon experiment, and it goes like this. Photons are what atoms are made of. Photons are light particles that the stuff of this world is made of. So it made tremendous sense that the researchers would want to do their experiment on the stuff our world is made of to see how that stuff is influenced by the field. So here's what they did. They took a single photon, some really sophisticated technology, allowed them to isolate a single photon, and they wanted to have two identical photons, identical properties. So they took the one single photon and they split it in two so that each would have identical properties. It used to be one photon, now we have two. They placed these two photons into a device, a specialized device that allowed them to shoot the photons, particles of light, if you can think of it in your mind this way, to shoot the particles of light through fiber optic cables in opposite directions from where they began. Each of the fiber optic cables was 7 miles long. So when the twin photons reached their target, their destination on either edge of this experiment, they were a total of 14 miles apart. And this is where the real experiment began. Because what the scientists began to do was they began to influence, the word they used was tickle. They began to tickle one photon in one place. And they were able to observe the other photon 14 miles away to see what might be happening in that place. What they found is that when they disturbed or tickled one of the twin photons in one place, the other one 14 miles away, it acted like it had the exact same experience, even though it was not directly being touched by the scientists. And they said, well, how can that be? When they would force one of the photons to rotate in a particular direction, the other one 14 miles away rotated in exactly the same direction. When they would charge, electrically charge, or remove a charge from a photon in one place, the same thing would happen without them doing it in the other place. They said, what does this mean? What is this telling us right now? This is what was reported to the journalists and was reported in the mainstream publications. The experiment was reported. The implications are where the controversy begins. Why? Why was one photon 14 miles away being influenced by another one when they were not physically connected? So this is where the idea of this field comes in. The fact of the connection, the term that is now given, a new term had to be coined. The term is called entanglement. Entanglement. And what entanglement means is summarized in the journal, the scientific journal that reported on the experiments. I'm going to read it to you word for word, just so we have the exact language. It suggests that once matter is joined physically, once matter is joined physically, because those two photons used to be one photon, it remains linked energetically even after the photons are split. Even when they are no longer physically touching, they remain energetically linked regardless of their location. Here's why this is important. It implies that once matter is connected, all matter is connected. Even when it is separated, even when something tears it apart, and that matter ends up on other sides of a room, other sides of a continent, other sides of a universe, physically, it's still connected.
The other part, well, this kind, I hope you'll come along with me. You'll have to accept it. Because it's the way nature works. If you want to know the way nature works, we looked at it carefully. Look at it, that's the way it looks. You don't like it? Go somewhere else, to another universe where the rules are simpler.
The twin photon experiment helps us to understand two things. Number one, why all matter was originally connected when the universe was formed some 14 billion years ago to begin with. And number two, why that connection still exists in our world and in our lives today.